So the name of this project is Processing Data with Python. The first thing we observe right here is the project structure. This tells us what are the list of tasks that are done. The first one is creating the data frame from pandas. The second one is reading the data from the files. The third one is cleaning of the data that is loaded. Then the data that is loaded gets analyzed and also subsetted in our last task. Let's go to the first task, that is data frame creation. To create the data frame, what we do is we import pandas, and then in the variable data we form our data using the dictionaries of the dictionaries concept, and the column names respectively are month, then rainfall and temperature. Then in the variable data frame weather, using pandas and dot data frame, we pass the data that we mentioned and we are able to create the data frame. Then to display the data frame, we directly write the name of the variable or the name of the data frame, and in the output you can see the data frame which gets created has been loaded with index and the three respective columns, month, rainfall and temperature. So in this 2CSV task, what exactly is happening here is on the data frame that we previously created, df weather, we use .2CSV and we name the file as rain.csv. So this file actually gets created in one of the folders in our desktop, and I have also placed in the output the screenshot where the file got created. Now that the CSV file got formed, so we can call the data frame as well. So this time our task is from CSV, the file we created in our folder, we will load the data from that folder itself. So we create a new data frame called df_rain, and using dot read CSV from pandas, passing the Windows file path, and at last you will see the name of the file. We actually are able to load the data frame from the file that we previously created in our folder. And to display the newly created data frame, we use df_rain, and in the output you can see the newly found data frame gets loaded. And now the next task is of dropping the unnecessary columns. You can observe here that after the index column, the very next column is unnamed 0, which is pretty useless, and we can just drop that column by using dot drop function on the data frame df_rain, and the parameters we have to pass the name of the column we are planning to drop, and since we are planning to drop the column, therefore axis has to be 1. And after dropping, we can check out the data frame again. The df_rain is displayed, and you can see in the output the unnecessary column has been dropped now. So in the next task from JSON, what we actually are doing is we are creating a data frame, and in this data frame we are loading the data from JSON file and not the CSV file. As we load the data from the CSV file, similarly we are loading the data from the JSON file this time. So from pandas we actually have to use .read underscore JSON, and we have to pass the Windows file path and name of the file we are loading, and we can see this data gets loaded into the data frame df_rain.js, and then to see the data frame that actually gets loaded, we can just print the name of the data frame, and in the output you can see the data has been loaded. Now when you want to fill the zeros instead of nan, you can see in the previous output at index 9 for the month October, the rainfall value is missing, and also the value of temperature is missing. 2 nan values are there, so this row has nan values, and if you want to fill zeros instead of these nan values, what you can do is in the data frame, which data frame you want to fill the replace the nan values with zeros, you have to write that data frame, and then you have to use .fillna, and using this .fillna you can actually replace the missing values with some value. This here we are using 0, we are replacing the nan values with zeros, so I've put 0 here. And then using writing the name of the data frame on which you have worked, you can display the output as well, and you will see in the output that 0 will get loaded instead of the nan values. But it's always a good option that you directly drop the nan values instead of replacing it with zeros. So to do that, what you do is, instead of fill now, what you use is dot drop now, and this will automatically drop all the nan values present in the data frame, and then simply write the name of the data frame and you can display the data frame. In the output, you can see at index 9 October was there, and for October there were two nan values for rainfall and the temperature column, and this time the whole row has been eliminated, which serves our purpose. The next thing is we do the rechecking of the data frame we created earlier, df range.js, and you can see this was the original data frame with nan values present. Now if at all you want to count the rows with nan values, then you can run this for loop. First you have to initialize the count as 0, then using the for loop we use two variables, index and row, and we iterate through the data frame called df underscore rain underscore js, and we do it row wise, so dot iter rows is used. Now this is the very important condition: if any row is null, it means if any nan values or missing values are present in the row, then the count will be increased by 1, and it will also get printed that at index such and such that nan value was present. And finally in the cell, what we do is we print the total number of nan values present in it, and we can print the count in this. So referring to previous data frame, we can tell there was only one nan value present at index 9. So here in the output you can see at index 9 there is a nan value present, and the total rows with nan value present is obviously 1, at index 9, the October one. So our next task is of mean. So we will use in this cell the latest data frame we have, which is data frame rain.js drop, and to get the mean we just have to use dot mean function, and you can get the mean of the columns rainfall and the column temperature. Similarly, to get the median on the same data frame, we just have to use dot median function, and you will get the median for the rainfall column as well as for the temperature column. And similarly, you can also get the standard deviation for the same data frame just using the dot standard function, and you get the standard deviation for rainfall column and the temperature column as well. Our next task is of subsetting. This time we are dealing with one column in this cell. So if at all you want to get the mean or median of just few rows of the column and not all the rows of the column, so you can do this subsetting. We are selecting the column rainfall from the data frame df range.js, and we are selecting the rows we want to deal with, first one, second one and the third one. So total 3 rows we want to deal with. So what we do here is we write dot mean function, and we are actually getting the mean of just those 3 values or just those 3 rows of the column rainfall, and its value gets printed. Similarly, if you want to deal with more than one column in our subsetting case, we just have to write the name of the data frame we want to deal with and the columns we want to deal with. Remember, this will have 2 brackets because we are selecting 2 columns, and then we can get the mean of those 2 columns, and you can see the mean of temperature column is 17 point something and rainfall column is 2 point something. Then setting of the index. We have observed in the previous data frames that index was like 0, 1, 2, 3, 4, 5, 6, 7, 8 and on and on. If at all you want to change the index, then let's say if we want to make month column as the index, as the base as a standpoint, then we can use the function on the data frame dot set index, and we can name the column we want to make index as, and then we can display the data frame of the changed index. Now in the outcome, you can see the month column has been converted into, or has been set as the index. Now since it has been set as the index, we can just call some of the values and some of the since it has been converted into the index, we can just refer to the index name, and we can just print the values of that particular index. So using lock to select a row and show its value, we are dealing with this data frame. So we write the name of this data frame, and then we use dot lock function to get the index called March, and then when we press shift enter, we get the output. The values for the rainfall in the March row is 1.94, and the value of the temperature is 15.00, which you can observe right here.